right. Our speaker is Mark Krawczyk, who owns and operates Keyline, Vermont LLC, teaching, designing, and consulting on permaculture design, agroforestry, natural building, traditional woodworking, and small-scale forestry for farmers, homeowners, and homesteaders. He and his wife manage Valley Clayplain Forest Farm in New Haven, Vermont. Thank you for being with us, Mark.
Well, thank you so much, Rosemary. And thanks for everyone for bearing with me doing this remotely, but I'm thankful we're able to make it happen. Is it possible, how many people are in the room? I just feel like I don't know who's out there. I see my Zoom faces.
Yeah, let me
Are you able to?
Let's see if I can turn this. Okay.
I'd love to make some virtual eye contact for just a second here.
Let's see. Let's see if I can do it through my phone. Can you see through my phone, Mark?
I'm seeing it. If you could just rotate it a little bit more. Hey, everybody. Excellent. Hi. I see you all out there generally. So welcome. Thank you so much, Rosemary, for making this happen into NOFA. Like I said, I'm Vermont based, and I'm actually in the midst of a permaculture design course up here in Vermont right now. So I'm thankful that we were able to make this happen, and I hope you all are having a great conference. And again, I apologize that we can't do the real FaceTime thing, but I hope I'm able to convey some of the passion and the concepts and the foundations and the potential for a lot of these practices in the next hour and a half. Rosemary and I talked before we got started here and discussed trying to leave the last half hour for Q&A. Also, though, I do realize that sometimes there's questions that come up that are really relevant in the midst of the presentation. So do feel free to kind of shout something out or type it. Sometimes I have a hard time keeping up with the chat, but for the folks that are remote, if it feels like it's really relevant in the moment, I'm happy to address it as it comes up. This is a subject that I've been really passionate about for a little bit over 20 years. And this is various ways of working with trees and trees and shrubs and the management for sprouts. And I'm kind of coming off the heels of a 10-year plus project of working on a book on this subject, a manual for this climate. And I also just want to acknowledge the contributions of a number of people along the way, namely Dave Jackie, who's been a friend, mentor, and cooperator in this project and contributor to this project on many levels. And so I now have this book out. I'll mention it a little bit later on as well, but it's really geared towards looking at the practice, the history, and kind of the how-to and the why, which in some ways is about the most important element of this whole discussion. Maybe I'll just say a couple things about my background too. I grew up in the suburbs and didn't really have a lot of connection to land management. I went to college at the University of Vermont and was introduced to environmental studies and really felt compelled to act as I began to learn more and more about the ways that my behaviors, whether they were conscious or not, were having impacts on people and places all over the world. And I was really lucky because I started to learn about self-sufficiency and Helen and Scott Nearing and the idea of reskilling. And during a semester overseas at an intentional community in Southeast India called Oroville, I learned about permaculture. And that totally just set this fire within that, continues to be this kind of lifelong journey to develop skills and understanding and just an appreciation for the natural world, as well as the way that people have come to understand how to be in and live in harmony with the landscapes that support us. And along the way, back in 2001, I read a book called The Woodland Way by Ben Law. And for folks that are interested in looking to, one of probably the most popular books of all time on this subject, I can't recommend The Woodland Way enough. Ben Law really helped sort of repopularize the idea of coppice forestry, especially, in North America. And I was just totally fascinated by the way he described his lifestyle and the livelihoods that all revolved around his relationship with the woodlands he managed. And so I was fortunate enough to be able to apprentice with him for a year, or for about 7 months, and get to kind of live in the woods and experience the seasonal rhythms of that lifestyle. And then, moved back to the States. This is about 20 years ago, and found that there was very little knowledge of this practice, or at least very little discussion about it or application. And so the past 20 years for me really has been one of looking at how to better hone some of these practices for our climate and our contexts, and also just learn from other people who are actually already doing this, but don't necessarily even think of it as coppicing. So a great place to start is just with a definition. And apparently the word originates from the French verb couper, meaning to cut. And it's a forest management practice in which broadleaf trees are cut during dormancy, allowed to resprout from the stump, and then harvested on cycles that can range from anywhere from 1 to 60 years. And a great way to kind of sloganize the practice is to call it cut and come again forestry. The idea, just like with salad greens in a vegetable garden, you can cut them and they'll leaf back out and we can harvest them again. It's that same idea, but in this case, we're doing it with woody plants. And just to be clear on some terminology that I'm going to revisit here in this first slide, woody plants would include all the plants that have wood, that make wood, trees, shrubs, and woody vines. And when we talk about coppicing, we're really just talking about trees and shrubs. So you'll notice here in this definition, I say it's a forest management practice in which broadleaf trees are cut. Most all broadleaf trees, which there's inconsistencies in the terminology often, which make it complicated, but we tend to think of deciduous trees. Most deciduous trees are broadleaves, but there's deciduous conifers. But most trees that make broad leaves and as opposed to needles will resprout when they're cut. There are exceptions, and there are a few conifers that will sprout when they're cut. The redwood being one that's especially magnificent. The pitch pine is one that's native in our bioregion here, which apparently it's largely due to its adaptations to fire in the ecosystem. There's a few of the pinyon and the pinyon pines and junipers in the Southwest. And then also, I don't get into it too much in this slideshow, but there's a practice called stump culture, which can be used to manage Christmas trees. It seems to imply that most conifers actually will sprout if they're cut, yet you generally will need to leave several whorls or a skirt of branches at the base, that you can't cut it all the way to the ground, which is what coppicing generally is. So a lot of terminology here to start, but just to say that most deciduous or broadleaf trees will sprout when you cut them. Usually this is done while they're dormant, and there's a few reasons for that. One is because the ground's usually frozen, and so that's a great time for us to do forestry activities, because we're doing the least amount of damage to understory flora. We're less prone to compacting the soil. Also, it really works well with the seasonal livelihoods of a lot of homesteaders and farmers. We're busy during the growing season with all our herbaceous stuff and tree crops. And so forestry really complements the farming lifestyle quite well. And also it's very heavy work, and it's really easy to work up a sweat even on a very cold day when you're doing this type of stuff. And then another reason is that it gives the new sprouts the entire growing season to develop and harden off before the next winter arrives. So you have that full length of time. And then the last piece I just want to kind of tease out here before we move on to the next slide is that this is the idea of like a rotational forestry system where we're harvesting from the same stump multiple times over its life cycle. And that can range from anywhere from as short as every year to perhaps as long as every 60 years, although that's pretty uncommon. More often, we'd see probably a 3, well, with like willow for basketry, it might be, every year. But, more often than not, it's a 3 to 20 or 25 year cycle. And so this is what we're looking at here with this picture is a sweet chestnut tree in Southeast England, where I worked with Ben Law. This tree was planted at this point about 180 years ago. They actually were establishing chestnut plantations for the polewood. Chestnut's a fantastic wood. It's quite rot resistant. It's a good fuel. It tends to split really nicely for a lot of different types of crafts, and it's very productive. And so they established plantations throughout much of the UK. One of the big demands for chestnut was for hop poles for the hop industry. And so this was a coppice stool, which is a stump that's being managed for the sprouts. You can kind of make that out down at the base here. And there's maybe 4 or 5 sprouts here emerging. And that's what that stool looks like after it's been cut. I'm going to cough for a second, excuse me. So we can see where the remnants are of those individual stems. Now, this isn't a great example of best practice for a new coppice stool, because generally you want to cut quite low to the ground. But because this stool has been managed over the course of probably 8 or 9 rotations through its life cycle, the height of the stool has continued to get higher and higher. And so you always want to cut into new wood as opposed to cutting back down at ground level. But generally speaking, we're only cutting a few inches above the previous harvest point. So if you're coppicing a tree for the first time, you're cutting the tree within just a couple inches of the ground. And what this is all about is these banks of buds that remain that allow the tree to regenerate new shoots following some type of damage. And so what we're seeing here in this case are these little banks of dormant buds that essentially are like the plant's insurance policy against some type of damage. It could be a windstorm that breaks off a branch. It could be browse from wildlife or livestock. It could be humans harvesting it, although the trees didn't obviously adapt to that evolutionarily speaking. But this really is this sort of evolutionary adaptation that woody plants developed to some type of disturbance. And those buds develop into sprouts. And I wasn't there for the next rotation of this tree, but if left to be, all of those individual sprouts that emerge will often self-thin to the point where you'll end up with 2 to 5 or 6 sprouts that can be left to grow on to maturity. So in the case of the chestnut here, this is a tree type chestnut, essentially returning a tree into a shrub. It's become a multi-stemmed individual, and that means that it's going to develop different types of products. And we'll get into that in just a minute, kind of the why. So here's just an example of moving from an uncoppiced tree, and another example of a chestnut here, single stemmed, cut for the first time. And that initiates a whole bunch of new sprouts that emerge. And again, often the strongest stems will win out, and the stool will sort of self-thin, so that you'll end up with, you might start off with 15, 20 or more individual sprouts, but they won't all necessarily make it to the first rotation. But in some cases, people will actually go in there and do a little bit of pruning and select, just as you might a fruit tree, in order to devote more energy to the strongest stems. And after harvesting, the first crop of coppice poles, you're going to end up with a whole bunch of individual little sort of stumpettes on the individual stool, and that process continues. So as Dave and I really developed the concept for this book, we found that, excuse me, I have one more cough coming here. I have a 6-month-old daughter at home who came back with a cough a few weeks ago, or a week ago, and now I got the remnants of it. When we talk about, when we talk about managing trees for sprouts, we can kind of think of it as a continuum. It's not that we just need to cut them at the base. We could also manage out at the periphery of the plant as well. And so we developed this term resprout silviculture. Silviculture just being the growing and cultivation of trees, or what we tend to think of as forestry. But a forestry that's really focused on managing for new sprouts that emerge after we, create this intentional disturbance. So on the left-hand side, we are looking at a linden tree in the Czech Republic that is, I believe, roughly 800 years old, and it's been managed continuously throughout its life cycle for the poles that result. And on the right-hand side, we're looking at a sycamore that's been pollarded or pollarded. And this is essentially a way of growing new wood or leaves out in the periphery of the canopy. The fundamental idea is the same, that we're not killing the plant when we harvest it. We're stimulating new sprouts, but instead of doing it at the base when we coppice, we're doing it out, along the ends of the branches when we pollard. And so what this really comes down to is this continuum of disturbance. And so, at the far left side, we think about an undisturbed tree as it expresses itself to its kind of idealized habit. Now, it's possible that that disturbance could happen just out at the very twig tips. There are a few plants where this does occur from a management point of view, like the tea plant for harvesting tea for, like green and black tea, where literally, leaves are being harvested out at the twig tips, and that's stimulating new sprouting that occurs right at the periphery. In the case of pollarding, it's usually either happening along secondary branches or primary branches, or even just down to like a single stem that elevates the shoot above the ground. The reasons why people would generally pollard is historically was because it allowed people to grow wood while grazing livestock in the understory. They didn't have to worry about the livestock browsing on the new sprouts and damaging them while they were still young and tender. It allowed for kind of a two-story system, very much like the silvopasture systems of today. And so that's one of the main strengths of pollarding. It's obviously a bit more complex because all of the management's happening up higher off the ground. It's much easier to cut a tree down at the base. But some of the other reasons that pollarding is useful is because it allows you to maintain this kind of, shade casting canopy that is limited in terms of how big the extent gets. So we see this a lot in Europe as a way of managing street trees for shade that is actually a bit lower to the ground, that the trees stay a little lower in stature. This was also really important to the silkworm industry throughout Asia. And it's also been a really important way that people have provided supplemental fodder to livestock over time, basically lopping branches during the growing season and then either feeding them to livestock directly or drying them and feeding them out in the wintertime, just as you would hay. Well, just to kind of help contextualize this, I find this idea of the disturbance severity continuum to be really valuable because it reminds us that, we can do the most extreme amount of disturbance by cutting the tree right off at the base, or we can kind of focus that disturbance out on the periphery of the plant. The ideas are all the same, though. It's about managing for sprouts. And, in our, let's see here, I feel like, there we go. So this is what a lot of the systems looked like that I was working with in England. They were often monocultures. This is basically a pure stand of chestnut. They tend to be very dense. There's a few reasons for that. One is that it tends to force the growth very much upright. And that's really important if you're looking for any type of craft or building material, any, crookedness or irregularities in the stems just make it harder to find good uses for them. Chestnut was especially useful also for all sorts of different fencing applications because of its rot resistance. The other reason is just that you tend to, theoretically, you can generate, more pole wood from the same area by packing things in a little bit tighter. So on a plant like this with a rotation that might be every 15 to 20 years, often the spacing would be between 8 and 10 feet per individual stool. So that's, quite dense. when we think about the potential for a tree that would otherwise reach, a 30 to 40 foot spread at maturity. Obviously, when we look at something like this, and it looks very ecologically, simple. It looks, kind of devoid of diversity largely. And to a degree, that is true at the patch scale when we just look at this individual patch. But the way that coppicing was traditionally managed was in sort of a high intensity, like patch cut rotational system. So that in like the perfect world example, you had 10 acres and you would do a 1 acre patch cut, basically cutting the entire patch each year in succession, so that by the time you got back to that first patch, it was 10 years old. And that would assume that the materials you needed got to be the size you wanted after 10 years. And this is more about the kind of ecology of these systems. The point being that while the individual patch is fairly is lacking in diversity, when you look at the stand itself, kind of at the landscape scale, all 10 of those patches, there's actually a high degree of what they call between habitat diversity, meaning that often it's birds, small mammals, and insect species that really thrive during the early successional stages of forest growth. Those young stages where the canopy hasn't fully closed yet. They're able to find all these varied habitats between these different patches. And it's reached a point where in the UK, they're really doing a lot of coppice for conservation because they found that there's been a coevolution of a number of different types of wildlife with this type of management. And so, there's certainly pros and cons to the coppice as it's been practiced historically. But that's what we're generally talking about with this kind of patch scale clear cut. And what's most important here, you don't have to clear a large patch like this, which, to be perfectly honest, in most forestry applications, a 1 acre patch cut is a pretty small patch. But what's most important is that you open up enough light that those stools are able to regenerate and grow, really vigorously. If you cut a tree in a, shaded forest understory, it may sprout, but it's not going to do so with much vigor. So it's really essential that that tree, that stool, gets flooded with light. And so the general rule that they talk about is anywhere from a ½ acre to 2 acres in terms of the scale of a typical coppice cut. But the important thing to remember here is that coppicing can happen at the individual plant level. It doesn't need to happen at this patch scale where you're cutting, a half an acre or an acre at a time. That you have a single tree in a field or a line of trees along a field edge, and all of that can happen at once. And as long as they're getting good sunlight, they should grow with quite a bit of vigor. But this is what, kind of your traditional coppice harvest would tend to look like. And this is actually what you'd call a coppice with standards system. You can see that large oak tree in the background. Coppice with standards was actually kind of the mainstay of forestry throughout much of Europe, all the way through the Middle Ages, and somewhat beyond, really until the industrial era. And standards describe trees that are allowed to grow to maturity as like single stem trees. Usually, they're not growing to full maturity. Usually they'd be harvested on rotations of 70 to 120 years or so. And they were generally things that also produced some type of mast. So they were included oak trees, chestnuts, and beech most commonly. And so that allowed for this kind of two-storied architecture. You had canopy trees that were producing timber, but then understory trees that were producing polewood. And in very short order, these coppice stools regrow quite vigorously. So this is probably only about 6 weeks after harvest in that same patch. And, the stools have already shot up, a dozen or two new sprouts that are 2.5, 3 feet tall. And it's not uncommon by the end of the growing season that these sprouts will reach 5 or 6 feet tall. And that's largely because they already have this intact established root system. And so the plant is ready to put out prolific new growth. And it needs to, because the canopy is where the energy is manufactured in the plant. So you've got this root system that's still alive and still productive, and this bank of dormant buds that are ready to generate new sprouts at following disturbance. And so this is what one of those coppice stools looks like up close. And you can make out sort of the faces of some of those cut stems from the last harvest. And these are, 1-year-old sprouts that are probably the diameter between your kind of index finger and thumb in diameter. And in this case, approaching 7 or 8 feet tall. That's going to vary by species, how quickly things grow, as well as by, the site characteristics. The more fertile the site, the more moisture that's available, the better the microclimate is all going to tend to, accelerate growth. But, when we talk about species like willow and poplar, which are, just incredible in their sprouting capabilities, they easily are going to reach, 6, 7, 8 feet tall in our climate. Whereas things like, oaks or hickories, they only might do 2 or 3 feet in the season. They're going to grow a lot more slowly. They're also producing a very different type of wood. It's much denser, has a lot of other utility, but tend to grow a lot more slowly. So this gets into a little bit of the why coppicing happens. And it largely results from 2 types of tissues that form new sprouts. One of which is called preventitious sprouts or dormant buds. And these are essentially these tiny little buds that the plant invests energy in forming during the early years of growth that basically lie, just at sort of the interface between the bark and the stem, and keep pace with the expansion of the tree each season. And they're present there as, again, kind of a little bit of an insurance policy. And when you really start to look, it varies depending on species, but oftentimes you'll find, dozens of these, if they're visible in a very small area. And they're especially prominent when trees are younger. Their ability to sprout is especially strong during the kind of juvenile stages between, 5 to 30 or so years. These preventitious or dormant buds seem to have somewhat of a limited lifespan, but they're essentially there only being called on, when there's some type of trigger that initiates their sprouting. And this is a little cross section of a black locust stem that I cut, and you can make out this little trace or bud steel as we move through, each successive growth ring here that originates back at the pith, which is, the origin of new growth as the tree expands, outwards and upwards through primary growth. That bud has just kind of maintained outward growth with cambial expansion as the tree adds new layers of growth each year. So it lies just kind of right, nestled between the bark and the wood, or right at the surface there. Here we see another one that's just been kind of exposed in cross section. We don't see the bud steel necessarily, but just to say that to a degree, these preventitious buds appear to maintain a little bit of a mechanical connection to the wood, that they're kind of nested within that stem. We also treat suckering, what's a practice called suckering or process called suckering, as analogous to coppicing, although it's technically different. Suckering describes new sprouts that develop from the root system of plants, of woody plants, and not all woody plants are prone to sucker. But, these are tend to be species that are, form kind of clonal colonies, things like staghorn sumac, the quaking aspen, black locust, our sweet gum, are prone to expanding outwards and forming, a bit of a clump. And they also have preventitious buds along the root system that allow for new sprout development. Often that's triggered when the plant's stressed. Sometimes it's just a mechanism for expansion, for forming that colony. We can leverage that practice in a similar way, but it is good to know if you're managing a suckering plant, because the moment you cut that plant, it's going to tend to send up sprouts all over. And it's hard to predict where those are going to come up. And so if you're in a smaller context, or you're in a situation where you're not excited about having black locust sprouts coming up, 10 or 15 feet away from the original plant, it's good to know that they're prone to that. But that can also be a real asset, because it, allows you to almost propagate new stems without having to do much of anything. I've used this kind of coincidentally with Native American seedling plums, because they also have this property. And if you do much pruning on a plum, or it gets, affected or by, insect damage or whatever, it can often tend to, trigger sprouting of new shoots. And often it's really easy to graft onto those young new sprouts and then dig up that sprout and transplant it somewhere else. So there's just some really valuable ways that we can kind of leverage this practice that go beyond just managing for wood products. And the other main category of tissues that form sprouts would be adventitious buds. And these, technically, they say that these arise de novo, meaning that they aren't actually buds that maintain that continuous trace back to the pith. They are essentially kind of like stem cells in that they are cambial cells, like within the cambium, that are able to kind of, when called upon, develop into, just about any type of cell or tissue for the plant. So in this case, we've got this sea berry stem that's been pruned back, and you can see all these young little sprouts that are emerging from that intersection between the bark and the wood. And this is in Greece on the right-hand side, and we see these adventitious sprouts on an oak stool that are emerging again from that interface. We often don't really get to choose where these sprouts emerge or what they tend to originate from. It's often been considered kind of common knowledge that adventitious sprouts don't maintain as strong a connection to the stem. They tend to be a little bit more vulnerable and weaker, and so that it's a little bit easier for them to be dislodged from the trunk when they're young. And this is another reason why we often tend, when we're coppicing plants, to cut really low to the ground, because the new sprouts that emerge from the stump are often going to come from preventitious or dormant buds that, if close enough to the ground, they can actually develop their own root system that helps support them and anchor them and make them a little bit more windfast. But essentially, these are the two types of tissues that we're managing for when we actually, coppice or pollard, are the dormant or preventitious buds and these adventitious sprouts or buds. And there's a number of different ways that these sprouts emerge, some of which we've already talked about. In the realm of forestry and arboriculture, epicormic sprouts are often very undesirable because they're unsightly. Epicormic technically means just upon the trunk. They're sprouts that form along the stem of the tree. And they're often a response to some type of stress. In some cases, it's because a bunch of light was opened up around the tree when it was cleared around. In other cases, it could be some type of pest or disease. But they can be used in a useful way through a technique called shredding, which I don't think I really get into in the slideshow, but it's kind of another variation on coppicing. They're not generally very useful to us because they don't tend to get very large in diameter, and they're often undesirable because if you're trying to grow timber, those new sprouts form all these little knots in the wood that lower the value of the material. We talked a little bit already about suckers or root sprouts, and I've mentioned the root collar sprouts or basal sprouts as being, often the most desirable for us. Rhizomes are similar to root sprouts, though technically they're different in that a rhizome is kind of a modified underground stem and not actually a root. And then lignotubers are these kind of specialized energy storage organs that we find on a number of different species. The one that's most prominent in our bioregion here is the basswood. And it appears again that that's just kind of this adaptation to disturbance. And in the case of the basswood and the linden tree, that's largely to browse from wildlife. But this is at the base of a young tulip poplar tree, and you can see all of these young dormant buds dormant sprouts that have emerged at the base here. So when we think about the life cycle of a coppice plant, the main thing I want to just get at here is the idea that to a certain degree, it appears that the act of coppicing or pollarding can actually maintain the plant in this kind of juvenile or youthful state. So we're starting off with a juvenile tree here in this graphic, and if kind of left to its own devices, it might reach middle-aged. And if there's no rejuvenating disturbance, eventually that plant continues to grow and mature, and ultimately will reach old age or senescence, meaning that it begins to kind of lose vigor and ultimately it'll die. And part of that is because of the ratio of canopy to the amount of new wood that the tree needs to generate each year. When a tree's young, the ratio of the canopy to the amount of stem wood that it needs, because every year the tree needs to add a new layer of wood to the entirety of the organism. As the tree gets older, the ratio of the canopy to that volume of new wood that needs to get added becomes less and less favorable for new growth. Whereas when the tree's in this kind of youthful state, it tends to be, very robust and vigorous. So with some type of rejuvenating disturbance, which in these cases, we're generally talking about coppicing, we actually kind of reset that ratio of canopy to new wood. And theoretically, we can kind of maintain that tree in this, juvenile state of growth indefinitely. There's examples of 2,000-year-old linden trees in the UK that have been coppiced throughout the entirety of the life cycle, a tree that might otherwise have a 200-year or 150-year lifespan that's been managed for 2,000 years. And we see, so we see that the idea of this type of management in many ways is sort of this symbiosis between humans and woody plants. So a key question is like, when we should coppice, both at what age and during what season. And so the graph on the left here is just showing that in this case, we're looking at oak trees, I believe in Wisconsin, and a study that was done looking at the percentage of stems at different diameters and how many maintained living sprouts. And we find that as trees get larger in diameter or older, they tend to sprout less vigorously. And so oftentimes, as I mentioned earlier, it's really best to initiate this process when trees are young. Once they start to get to be, over 30, 40, 50 years, just the vigor with which they're going to sprout is a lot less. And I mentioned this a little bit earlier, but normally it's really ideal to do any kind of coppice management during the winter months or dormancy, depending on which climate you live in. And I already talked about those reasons, so I won't say them again. The only thing I'll add, though, is the exception would be if you're pollarding for leaves, you're going to have to cut it when the leaves are out. And so normally that would happen, we would probably be getting to about the tail end of the optimal time to be harvesting. You could still be lopping branches, beyond this point in the season if you'd like to. But when it comes to I can't really get into the details here, but when it comes to the nutritional and digestibility characteristics of leaves on trees, we find that as they get more mature, as the season progresses, the digestibility and the crude protein and just the overall value of those leaves as feed starts to diminish. So we have more volume as we get to points later in the season, but the value of the feed becomes less. And so oftentimes for folks that are thinking about cutting tree hay that they're going to harvest and store for winter time, it's kind of the, late July to, early mid-August is kind of your optimal window. This slide just speaks again to that kind of longevity idea that I mentioned in the previous slide. We're looking at a chestnut stool on the left in France. And you can see how massive that clump has become and how productive it is. That's only 2 years growth on that tree. And then on the right-hand side, we're looking at a 500-year-old beech tree in an ancient silvopasture in an old wooded commons outside London. And that tree hasn't been managed now for 200 years. So those sprouts that we see, they're no longer sprouts, they're trunks up here, are 200 years old. And you can notice how the bark's begun to flake off the tree. For lack of management, these trees actually enter that old age or senescent stage. And so, coppicing becomes this really valuable tool for trying to rejuvenate and keep plants young. Here's just a few different examples of, some of the coppice stools I've been nurturing over the years. We've got a couple different types of willow and poplar here, which are some of the easiest plants to start with. And the great thing, one of the things I would highly encourage folks to do is, if you have species that you tend to consider undesirable because they're classified as invasive, the worst case that happens when you coppice an invasive plant is that it dies. And the best case is that you find some useful outlet for it. So in my case, with things like common buckthorn and Japanese honeysuckle, which are two of the species that tend to popularize our more thickety zones on our landscape, the sheep we raise a small flock of sheep, and the sheep seem to be quite happy to browse on those leaves. And so, a great way to practice with this is with things that really are inconsequential to you if they don't make it, although most species will sprout when you cut them. So here we can kind of see the original stem as it's getting subsumed by the new wood growth and the new set of sprouts emerging. This is corkscrew willow, which is kind of an ornamental willow that we're growing for more of a nursery or a floral industry product. And then here we've got some hybrid poplar that already, has overgrown that original cut here. In this case, we've got black locust. You can see the original stem. And this is probably only about 3 or 4 years old when it was first cut. And, the new sprouts are already larger than the original trunk. This is another corkscrew willow that I managed this year, just cutting more as a pollard, kind of out at the periphery of the plant. And you can make out just within, a few weeks of the start of the growing season that, there's a wealth of new sprouts that start to emerge. And if I have the time, I'll often go along and just kind of prune off, just strip off some of these extra sprouts that emerge, because I don't necessarily need, 100 new sprouts emerging along this trunk. I don't go too crazy with it, but just the idea of concentrating more of that energy into less sprouts can often be a good one if you have the energy to do it. We've planted seaberry or sea buckthorn as a bit of a nurse crop in some of our more orchard and berry rows. The idea of kind of a nitrogen fixing companion plant that we can use as the chop and drop mulch, as folks may be familiar with in some of the more permaculture and syntropic agriculture practices. And so when you plant out these were all unsexed sea berries. So we had male and female plants. If they've fruited, we've just left them to grow on to maturity. But if they're male plants, we've started pollarding them out at the periphery here. And then as this new growth develops and matures, we can just, use it as a woody mulch that we cut and and just drop right around the crop plant. So this is one of the ways that, coppicing can be useful to farmers, is just, growing mulch in situ for whatever it is that your actual crop is. A few different examples of pollarding and the training that goes on to actually sculpt these trees and their architecture in order to kind of optimize this shape for either shade or for leaf production or for pole wood. Usually pollarding would occur on rotations of 3 to 7 years for tree hay or fodder for livestock, and anywhere from 10 to 15 years for firewood. But in many of these applications, what we're looking at are more ornamental street trees in Europe. But the difference again with pollarding is that it's largely a process during the early stages of the plant's life of actually training it to this architecture so that it has all of these nodes or knobs where you'll cut back to, just like a coppice stool, in order to initiate new sprouts. And those points become kind of locked in place in time as continual points to harvest back to. And then one more practice I just want to mention, because it has a lot of utility to homesteaders and farmers, is the idea of living hedges. And these were very common throughout much of Europe because prior to the advent of wire, we either needed to use trees or stone often as ways, or wood as ways to enclose livestock. And and partition off fields. And one of the challenges with a living hedge is that as the plant gets taller, the lower branches tend to die. And so if you're trying to keep livestock in a field, as the hedge starts to get gappy, it becomes much easier for the animals to find their way through those gaps. And so hedge laying essentially is leveraging the same sprouting response that we find in coppicing plants, but instead of cutting the plant off all the way at ground level, we're actually leaving just a small little strip of wood that allows for a cambial connection between the roots and the top of the plant. And these plants are often very dense in a row, between 8 and 12 inches. They may be a single row or a double row, and the book gets into some of the kind of best practice when it comes to species and layout, etc. But the idea being that we don't cut the plant altogether at the base. We leave those stems intact and kind of lay the remnant pleachers, is the name for a tree that's being managed in a living hedge like this, kind of diagonally. And this disturbance here creates a strong sprouting response both from the stump and along the trunk. And within a season, it's just a wall of green and just this dense vegetative partition between fields. And so hedge laying also kind of fits within this toolkit of resprout silviculture. So I'd like to shift gears a little bit and talk a bit more about the why, because for a lot of us, that's the most important question, is like, how is this useful to me? And so this all comes down to the products and the economics of these systems. And the most important piece to this is really just recognizing that it's all about the polewood economy. For most of us that are involved in any type of forestry, we tend to think of stems that are smaller than 12 or 15 inches as being relegated to the realm of firewood and little else. And once we get much below 8 inches or 6 inches, there's very little utility in that material. Whereas for people throughout history, smaller diameter wood was much more useful to them because they didn't have all the sophisticated tools and equipment and machinery that we have today to transport it and process it and harvest it, etc. So this is all about finding different uses for smaller diameter wood. And I think a really valuable way to think about this is along a continuum of added value. And so if we start off, kind of at one extreme of that continuum, we have, high volume, but really low value. So that would be, essentially wood chips. And that is actually a useful product that can come from, Coppice managed woodlands, or in certain cases, it's almost more of an agricultural enterprise when we get to that level. And we've seen some really great work that's come out of SUNY Syracuse, the Environmental School of Forestry, and a number of other practitioners that have been looking at, these intensive short rotation forestry systems, usually using hybrid willows or poplars as ways to create a more renewable biomass energy source using, coppicing on very short rotations, often just a couple years. The only thing is, at that point, we're talking about, $20 to $30 per ton for the value of the materials. As we move along that continuum, we see, with imagination, with access to markets, with skills, with tools, there's all sorts of different opportunities to add value to those materials. And, we get to the other end of that continuum, and it may be artwork, it may be, living sculptures, generated from that same raw material. And so there's all of this potential for what do we do with the materials that come from coppiced wood. And this is kind of where the art of the management and the business development side of things lies, is in, kind of figuring out either what skills do you already have or passions do you have for, working with wood, or are there unmet demands in your locale and opportunities to create a new niche or a new product. We're going to talk about a few of these briefly, but looking historically, some of the mainstays of traditional coppice would have been charcoal, which was massive because of the need for it as an industrial fuel. as well as fencing. And so in this case, this man is an itinerant worker who's built a seasonal shed and as seasonal hut as he's moved into this patch of coppice woods. He's gone in, harvested materials, and he's made what essentially were like the precursor to electronet fence, these movable fence panels. They're called Sussex hurdles or gate hurdles that are individual fence panels that could be used to rotationally graze sheep. And you can make out the stack there in the background. And here we see a gentleman that's laying a living hedge. These are some of the examples of different chestnut products that might come out of a managed woodlot. In this case, these are poles for yurts that are selected for straightness and diameter. Fairly small in diameter for this, just a couple inches to 3 inches in diameter for most of those materials. There's a lot of woven products that coppicing suits perfectly because it tends to produce really straight, unblemished, and flexible materials. So woven fences using a technique called wattle, which is a series of uprights with weavers in between. It's very common, as well as willow for all sorts of different baskets. And then we're looking at fence posts here where durability or rot resistance is really essential. So, that becomes a really important species consideration. There's an example of a willow wattle fence. In most cases, this is decorative, whereas historically this was, one of the essential ways of, again, kind of maintaining enclosure around fields. And all sorts of anything wicker is generally going to be the product of some type of coppice management, because the materials that coppicing produces are just, kind of second to none when it comes down to it. I visited this man in France about a decade ago who has a family business making chestnut shingles and split shakes. And so they make, roofing products from chestnut that's coppiced on a 30 or so year rotation. In this case, we're splitting materials out for, I don't recall what the product was for this, but using techniques like riving as really quick and low-tech ways to process materials into smaller diameter. Instead of using a saw to rip materials along their length, we're just splitting them along the fibers, which also makes them a lot more rot resistant because we haven't severed the grain as we've cut through them. Different examples of fencing products. And this is an old building in Bulgaria that uses wattle and daub as a wall structure. The building is kind of left derelict, but you can at least see the internals of that, woven framework. It's the man in Norway harvesting leaf hay, tree hay for his livestock. And this man is, hanging it to dry so that he can feed it out just as you would hay in the wintertime. One of the ways that we've incorporated some of these practices into our farm is by you just giving access to some of this, in this case, black locust with our sheep as we move them through rotations. This is a patch of about a half an acre of black locust that we planted with the longer term goal of harvesting pole wood for building construction and or fence posts with any of the materials that aren't, the proper diameter or aren't straight enough or high enough quality to be a really high value fuel wood. But in the meantime, we're happy to let the sheep browse on the lower branches and any remnant sprouts that might emerge in the rows between. And also it's been super valuable as a shady protected zone for them during the heat of the summer. Just having some additional shade in a field is something that's really nice. Obviously firewood is really important, and that's one of the reasons a lot of homesteaders are interested in this, is just becoming more self-reliant when it comes to their fuel wood supply. One of the practices I think that is especially useful to most folks is just for getting up quick shelter and screening, and that's where some of those fast growing species I mentioned earlier, like willows and poplars, are really exceptional. They're often very inexpensive to propagate or cheap or free. You can do it from hardwood cuttings, and they grow very quickly. And, if you're looking for some type of wind protection or, privacy barrier or other type of shelter, those species are really top notch. And again, they're so hardy and durable that, you can really kind of learn the hard way on species like that. So these are hybrid poplars here that you can't really make out in the canopy right now, but I've pollarded those twice in their 8 years of life. And within, the first season, they've sent out 6 feet of new growth on most of the new shoots. So they're just incredibly hardy and fast growing. And they also can be lopped and fed to livestock, either as they're kind of moving through in a rotation or kind of in a cut and carry situation. I mentioned charcoal already. We grow a lot of shiitake mushrooms on our farm. The diameter of the materials that we're looking for is almost perfectly suited to coppicing, and the dense hardwoods that are best for growing mushrooms are also quite good at coppicing, although they will take some time to get there. With oak species, we're probably looking at a 20 to 25 year rotation. And so in the meantime, we're really focused a little more on timber stand improvement cuts when it comes to how we harvest material for shiitakes. But when I realized that oyster mushrooms actually really thrive on some of the softer hardwood species like box elder and willows and cottonwoods and aspens, that kind of flipped my whole mentality around the value of some of those species, because those are quite easy to get a 3 to 6 or 8 inch diameter stem in a much shorter harvest rotation. And so oyster mushrooms on some of those soft hardwoods that have been coppiced is a great potential product. I've been a bit of a woodworker throughout my career, and rustic furniture is also something that's really well suited to a lot of the small diameter stuff. In this case, I didn't actually make the chairs. I wove new seats on them using hickory bark, which harvesting bark from these plants is also another potential market opportunity. And then if you're in a more urban locale or a place with a bit more commerce than I am, where I am here in more rural Vermont, the opportunity for floral products through what's known as woody cuts is perhaps one of the most lucrative opportunities out there. And this might be things, in this case, we're looking at red osier dogwood, which this man, Michael Elsterman in Michigan, he manages this kind of wild stand of red osier dogwood along the margins of an interstate highway. And he and his family make wreaths and other type of woven crafts, and also just floral presentations with this because of the colorful stem. But that's one of the reasons why we've been experimenting with corkscrew willow as a product, but also things like hydrangeas and flowering cherries and quinces can be, they can generate on the order of $3, $4, $5, or even $8 per stem, depending on the market you're in. Obviously, we're talking about very high value product with less demand, but I've met several people along this journey of learning that make a respectable income from doing exactly this. And then there's also opportunities, as I mentioned earlier, to do kind of some of this living sculpture. This is a living willow fence crafted by a basket weaver in Oregon named Margaret Mathewson. And these are some of her wares that she makes from willow that she coppices. And we've been seeing, as the idea of green burials has been growing in popularity, the idea of woven wicker caskets being another niche for folks to explore. And we're looking at some pollard trees here in Madrid. These are London plane trees or sycamore trees. And you can make out, where those nodes of new growth were. I'm going to guess this is at least 15 years since that last cut. And I just have a few more things I wanted to touch on here. I'm going to jump through a few slides because I'm looking at the clock. We're looking at some different examples of pollarding in Europe, but a few principles that I think are really key, and then we'll open it up to questions here. So I mentioned this already, but I can't overstate the importance of light. It's really important that you optimize light. So you don't need to open up that half-acre clear cut or that acre clear cut, but you do want to make sure that your pollarded tree or your coppice stool gets a lot of light. Usually we're going to harvest during dormancy, which often is going to align itself really well with our seasonal practices too. We're often going to want to cut low on the plant to stimulate those sprouts from the base of the tree. And if you're doing this in more of a traditional kind of coppice system, patch scale rotational harvest, it's nice to keep the stands dense because it makes the growth upright and straight and kind of generates more wood from the same area. Ideally looking for ways to diversify, and that could be thinking about a 2-story system with like a coppice with standards type approach, or having different species of pollards within that same patch, or also thinking about opportunities for understory growth. So in our black locust stand, during the early stages, we had planted raspberry suckers in between the trees, and we were able to at least get a modest harvest. I don't think it was really worth it, but we also popped a bunch of young rooted cuttings from red and black currants into the stands between, and at least for the first few years we were able to get a harvest before the canopy closed. And I'm curious to find out if they will continue to fruit under this dense canopy light, and then also once we cut that stand, how they'll respond as well. So I wouldn't necessarily recommend that, but just looking for ways that you can diversify and think about some of the different layers of potential growth within the patch. Adding value, always looking for the most creative, high value use for the highest quality materials, and then having this kind of continuum of potential so that you have, the scrap even becomes kindling, or it's brush that you're using to try to stabilize and restore a eroding channel on your property, perhaps in a riparian zone or something to that effect. But looking for all sorts of opportunities to harness the utility of these materials. These things get a little bit more into that more patch scale management when you're thinking about how you might transition an existing woodland into coppice, looking at sort of how we define where individual patches might lie within the landscape. And if you're doing this again at a scale where you're working within an existing woodland, I can't overemphasize the essential nature of good access. Convenient access is really, really crucial. That you want a reliable way that you can get in and harvest materials and remove them. You want it to be as low angle as possible so it doesn't create issues with erosion. And you want it to be as extensive as can be while having the most minimal footprint as possible. And then the challenge for a lot of us is going to be, how do we protect from browse? And in some cases we can't. Fortunately, and when I'm talking about browse, for a lot of people, it means deer, because these succulent young stems are really pretty optimal food for wildlife. And so in some cases, it may be just managing more plants than you actually need. In others, it may be that you try to, maintain a presence there just to try to distract and divert wildlife. In others, it's just accepting some of those losses and knowing that that's just part of the cost of doing business. But I would like to transition and open things up to some questions here. And if there's not questions, I have a few more slides I could touch on, but I'm guessing that there's should I stop the share maybe, and then we can do questions?
Let's stop the share and we can start some questions. Thank you for that presentation.
Great.
Yeah, excellent.
You're welcome.
That was wonderful.
Thanks.
I have a question. Can you coppice or pollard American larch or tamarack?
So as best I know, no, because it kind of fits in that conifer category. But I mentioned briefly that idea of stump culture, which is a way that you can, it seems, manage many types of conifers, often used for Christmas trees. By, instead of cutting down at ground level, you're going to want to leave at least a couple of whorls or branches. It depends on how big the plant is too, because if it's a mature tree, I don't think it'll sprout. But if it's grown, if it's more open grown and it still has some low branches so it can photosynthesize, it's quite possible that it will sprout. I can't tell you definitively that the answer is no, but it's not generally known to be a coppicing species. I would love to be proven wrong on that, though.
I'll let you know.
Great, thanks. Are they, just out of curiosity, are these more mature trees that are kind of in the polewood or sawlog size, or are they younger?
They're younger.
Yeah. And what would be the reason why you would want to coppice them?
See what happens.
Yep. It's to see what happens, did you say?
Actually, I would use, maybe a 4-foot wide stump a 4-inch or 8-inch, 4 to 8-inch wide stump for a fence post, because it's very rot resistant.
Yeah. So I would just recommend, if it's possible, to if there are any low branches that you could leave, I think that would be valuable, just because it seems that many conifers can, maintain that capacity to sprout, as long as there are still some branches that are intact.
Thank you.
You're welcome.
Yes, so for the small landowner, if I have like an acre of wooded land
Yeah.
and I'm doing like a quarter at a time to open it up for the light, would that be enough to do the coppicing?
Yes, it should be. That seems like that is kind of on that. So the big question with the light is it's all about the height of the surrounding canopy. So if all the trees around it are, the size of the gap is the larger the taller the canopy, the larger the gap needs to be in order to minimize shading. And so if the canopy is not exceedingly tall, then the gap doesn't need to be nearly as big. And depending on how this is oriented, you might be able to move in a way where you start off on the southern edge. And so you open up light on the south first, and then you move to the north, or then you move, from the southeast to the southwest, to the northeast to the northwest, or something to that effect. A couple things I will say, because I didn't really get into this, is if you were looking at coppicing an existing stand of woods, there's some main questions that I'd want to look at first, which is, how old are the trees? How big are they in diameter? And what species are they? So some patches are going to be much more valuable and desirable to coppice than others. If you've got a lot of conifers in the mix, it's really not going to coppice in the true sense. So I'm assuming that you don't have a lot of conifers there. The denser the stand, the better off you're going to be. So in a lot of ways, it's like a more of a thicket stage, or an old field stage of young forest growth is going to be one of the better candidates for this, as opposed to, if you had a nice patch of, diverse multi-story, you've got some canopy trees and some young stuff coming up in the understory and a few layers in between. I would say that you'd probably be better off just trying to do good, what we call uneven aged forest management, which would be like kind of selective thinning. This all comes back to your goals too, but it's hard to give any prescription from a distance here. But just to say that I want to make clear, I'm not presenting coppicing as being in any way better than typical forest management or forestry silviculture. It's a complementary tool. And so for me, it would depend on the species that's there, their diameter, because if they're really big, they're probably less prone to sprout with vigor. And then another thing would be, if you do have a lot of, invasive species and pressure around, you just want to be aware of that. If the stand isn't already dense and there's not a lot of young trees already growing, that you open up that big patch of light, and it's going to create a great opportunity for species you may not want to move in, that are really well suited to that early successional stage. But in short, to answer your question, yes, I think that would be fine to do this kind of patch scale rotation. If you have a follow-up question, I'm happy to see if I can answer that too.
Well, the follow-up question would be, if you did 1/4, say it is desirable wood and dense enough, then when would you do the next cutting?
So that depends. I guess in the way I would tend to think about it is like, what do you project as your rotation? So if you're imagining it's, you want to be returning back to that first patch after 10 years. The question is, what are you using the material for ultimately?
Like wax patching?
I'm sorry, for what?
Straddle fencing?
Oh, okay. So then in that case, you want it can be fairly small. So that could be, once per year. And you'd have a 4-year rotation. And so by the time you got to that first patch, things might get decent sized. It might be a little big for wattle in some cases. But you're going to have a range of material sizes and you'll sort things accordingly if that's the case. But let's say if you wanted to grow firewood, you probably want to wait till it gets to be in at least sort of that diameter range. And so you're going to need to wait until it's gotten to that size. So if you had 1 acre that you split into quarters, maybe it's every 3 years you'd harvest another patch or something like that. So you have this, longer rotation kind of built into that.
Okay, thank you.
You're welcome. I did see a question from Richard in the chat here. I'll just address. I think he brought up autumn olive, and yeah, I actually leave autumn olive trees, shrubs, nitrogen fixing, grow like crazy, forage, leave strategic coppice trees for nitrogen fixing about a growing area. Is it possible to use for mushroom growth, firewood, mulch, biomass, etc.? And they are free. I love free, and I think that is one of the best applications. I mentioned it briefly earlier, but I'd love to echo it, is that the stuff that grows, that just wants to grow and grows for free, that you don't have to plant, are the best candidates for this. In the worst case is that you kill them. So a species like that, if it's already established, I would highly encourage you to do it. We have autumn olive on our property, and I've actually had some that have died from coppicing, which a lot of people work hard to kill them. So I found them to be a decent browse for our livestock. They are nitrogen fixing. I do like the berries. The wood hasn't gotten large enough for us to really use it as firewood, but we've used it just as like mulch, or also we've been making biochar seasonally and use that as, a soil amendment that we apply. And so for all those reasons, and I don't know about mushroom growth, so you'd have to experiment with that. I've not seen any info on it, but it would definitely be worth a try. But I think that's perfect, is because we run into this issue where it's like, there's what you want. So sometimes there's a product that you want to grow. We want to grow our own firewood, or we know that we want to make this product and we're going to need this species, or these species are best suited for that. But in other cases, it's like, I already have all these species. So learning about what are the properties of those species is, a key place to start, because it might start to open up new opportunities that you don't otherwise see. So I would definitely encourage folks to start to look at what they have that's growing free already on the margins, and work with them, because they also tend to be really, aggressive at sprouting. And I see Susan Shane wrote, they are thorny, though tough to handle. I found them to be thorny on the young branches a little bit. But the funny thing is that a lot of the species that, like black locust is another that has quite a few thorns, especially on the young growth. As it gets older, you don't really find them so much. But especially in the hedge laying realm, it's like we're often looking for thorny species. And so, yeah, having a good set of leather gloves can be nice with some of these things for sure.
One of those is part of the auction.
Yeah.
I got a good set of leather gloves.
Do we have other questions in the room? No questions at the moment.
Well, actually, I do have.
Oh, I'm so sorry.
If you have an older apple tree that hasn't been taken care of, I'm not my own, but my neighbor, it's still producing apples, but they're way up high. Can you pop some apple tree?
You certainly could. At an older age, as I was saying earlier, a lot of species lose that capacity to sprout with vigor from the stump at an older age. I've seen people like aggressively top work graft apple trees, depending on what variety. If this is just like a wild apple tree, or if the fruit is of a good quality, then that may be less desirable. But often on older mature trees, people will cut them way back in almost like a pollarding type of structure, and then graft other varieties onto the tree. So that could be an option as well. I'd be a little concerned that it might not come back with the vigor that you're looking for, because like I said, it's chestnuts, oaks, redwoods. There are a few species that will coppice as they get, on into maturity. But with some species, they just kind of lose that vigor. They're slower to rebound as they get older and more mature.
Oh, yes, go ahead.
Is there like an optimum height off the ground to cut for coppice?
If you're pollarding,
No, just cutting the stump.
the coppice stool, yeah. I mean, on the first cut, I usually leave just a couple inches above ground level. So getting pretty close to ground level. And one important thing that I'm glad you brought that up, I should mention, is that it's really key to remember that the stool or that stump is part of the product. Like, you're trying to nurture and nourish that thing because you want it to continue to persist over time. And so if it's a tree that you're actually having to fell, you're not just it's fairly small and you can kind of cut through it with a handsaw and drop it, or even so, you're still felling it. What can often happen if you don't, depending on how you cut the tree and how it falls, sometimes there'll be a strip of bark that'll stay attached, or you'll get some splitting or tearing that happens. So it's often a good idea to make your initial cut a little bit higher than the finished coppice cut, because you want to leave that stump in as clean and even as possible. You don't want there to be pockets where water can collect or a bunch of ragged tissue, or you don't want to tear off a chunk of bark. So it's often good to make that first cut, not unlike you would, if you were pruning a larger tree limb, that you make the cut a little bit outward so that the strain on the branch doesn't cause a big section of bark to tear off. It's kind of a similar idea. So it's good to make the initial harvest cut like a little bit higher, and then come back and make that final clean cut just within a couple inches of ground level. I see another question in the chat here. Nancy mentioned, I mentioned diversifying and underplanting. Would it be viable to try to have trees like ash and poplar to be pollarded and a quick growth willow to be coppiced annually beneath? I want to grow fodder and tree hay for livestock. Yes, I think it would. That would come down to the patterning and the spacing. So as things get more and more dense, it's going to be harder and harder for light to reach those lower stories. And so depending on how you imagine this system looking, that's one thing I didn't really get into here too, is just kind of how we develop systems around all of these individual pieces that we talked about. But we could be imagining this like kind of patch that's dense planted with trees and shrubs, and it becomes this kind of block of fodder that you're growing and harvesting and moving to the animals as you harvest it. Or it could be more of a silvopasture situation where maybe you have belts of trees with lanes between them that the animals can graze. And so you have a lot more light that's able to reach the tree rows, and the animals are benefiting from some of the shade that they get from the trees, etc. So if that was the case, like what I would probably imagine, if you were pollarding, ash or poplar, maybe those ash or poplar trees are every 15 or 25 feet even, depending. This all comes down to how much space do you have, what's your landscape, your landform and your solar access and goals, etc. But and then you could do willows on much tighter spacing within the row in between. So maybe those are every 5 feet, and so every 15 or 25 feet you've got your ash or poplar, and then every 5 feet or so you've got your willow in between within the row, as opposed to imagining it as more of like a dense patch where you've got this kind of 2-story system. I think it'd be nice to have space to work around. And so maybe those rows are probably a minimum of 30 feet apart is what I've found to be kind of on the low end of, on the narrow end of what's adequate. And if you can go wider with that, it's even nicer if you're grazing animals between, just because moving electronet fencing, which is what we use for sheep, it becomes kind of a narrow paddock. So it's a bit of a design question, but you could definitely do it. I would just say something about ash is that there's been some questioning around whether, because it seems like I don't know how extensive the emerald ash borer damage has been where you live, Nancy, but it's starting to make its way up into Vermont. And I grew up in Wisconsin where it's just decimated the ash stands there. It does seem that the trees need to get to a certain size before they succumb to it, from what I understand. So it's possible that you could still kind of coppice ash in a way that it could be useful without, kind of losing it to pest damage as it gets more mature. But if you were planting something, I'd probably be prone to look at a different species, especially if you're pollarding it, just because I would be concerned that, that more mature trunk would be susceptible to the emerald ash borer as it got older.
Yes, go ahead.
Yeah, Mark, thanks so much for being here. My question has to do with, I'm wondering if you can speak to prescribed burning, and the way in which species that resprout respond to fire as opposed to cutting. And then on top of that, I know just different regulations in different states around home scale prescribed burn that I'm trying to find out more information. Researching it has been kind of challenging.
Yeah, I can only speak a little bit to it. I've learned a bit about it just from some research and work I'd done out west, but it's not part of my toolkit really. I do think it can be a valuable tool, and it's the way, as I understand it, that many indigenous people essentially coppice landscapes and manage landscapes. Out west, there's been a lot more work that's gone into prescribed burns for all sorts of ecosystem benefits, as well as just like mitigating fuel loads. I don't understand fully how prescribed. I still think it's like you still have to cut the stem from the stool. It will sprout as well, but I don't understand how you fully manage like the stool health with the prescribed burn, because I don't, in my world, I have a chainsaw, I have hand saws, I have lots of ways that I can cut the tree easily. So the value of burning for initiating coppicing isn't as valuable to me, because I can make pretty clean cuts on the stump, and that's going to trigger sprouting effectively. But as a way to manage understory as well, I think that has a lot of potential. I see it here and there in Vermont. I can't tell you much about regulations. I could say more, but I feel like I'm not giving you a very complete answer. So if you have a follow-up, I'm happy to see if I have anything to add, but.
Thank you.
Thank you, Mark.
You're welcome. Yeah.
Other questions in the room?
And the ones in the chat were addressed, I think.
Yes, they were. And Nancy brought up a book called Sproutlands, which I would definitely recommend for anyone that's interested in a really beautifully written narrative surrounding some of the traditions of these practices around the world. Sproutlands by William Bryant Logan, I believe, is a great book. And it's kind of a nice complement to my book, the Coppice Agroforestry book, because while that Coppice Agroforestry does get into the history a bit as well, and it's a bit more of a manual and a how-to on a lot of these practices, which Sproutlands tends not to get into as much. So Sproutlands is really, really a wonderful read. And she was bringing up that ash was commonly used as livestock fodder in Europe, which is correct. And yeah.
And I think someone said that your book is on sale downstairs, is that right?
That's true, yeah. And so my book is on sale downstairs, and for anyone that's interested outside of this realm too, I sell it on my website, on our farm website, which is valleyclayplain.com, Valley CLAYPLAIN.com. And I thank everybody for your time and your attention. It's nice to be able to be here as much as I've been able to. I apologize for some of my my coughing fits there, and I'm glad I was able to pull it together.
Thank you so much.
And
Yeah.
yeah,
I know it's hard for you to see like everyone in the room, which must be a strange experience. But I think we have one last question, just to repeat the website, your website, right? You want to repeat it? Yeah.
yeah, it's Valley Clayplain. So CLAYPLAIN, like the plains of Spain plain, valleyclayplain.com.
Perfect. Wonderful.
I hope you guys have a great rest of the conference. Thank you to NOFA for doing this. You guys are doing amazing work, and I hope people can get out there and just have fun learning from and working with trees and shrubs and building community along the way.
Wonderful. Thank you, Mark.
Thank you, Mark.
My pleasure. Thank you all.
Thank you, everyone.